Hello, Algebra 1 CP students. Hopefully you're having a great day so far. Today what I'd really like to do is wrap up our discussion on inequality word problems by showing you a couple word problems that actually equate to compound inequalities as opposed to just regular. However, even though that may sound a little scary, you're going to notice that they're really the same thing that we've been doing before with regular old inequality word problems and just solving inequalities in general. The only difference is we're now going to see the words like we want to get a value that's between this and this, or we want to get a value that's more than this and less than this, or how about something like less than this or more than that. So you're going to see that it's very, very similar setups, very, very similar scenarios, but you're going to see those different keywords showing up along the way. Just so we can, again, be comfortable with compound inequalities, I do have a couple of do now problems that I would like you to try. I would actually encourage you to pause the video and try these on your own. We have an or problem here and an and problem here that we need to split apart our little inequality sandwich. Like I said, I encourage you now to pause the video, see if you can do these two problems. Take about 5 minutes, and I will come back to you. All right? Press play when you're ready to keep going. All right, I'm going to wait long enough. I suppose that by this point, I hope that you've paused, tried them on your own, and see what you're going to get. We're going to go over them right now. All right, so in order to deal with this first problem, really in order to deal with both problems, what we're going to do is we're going to solve each of the inequalities independently and then just graph the solutions together on a number line. Remember, when we have an or problem, we're really looking to see what regions of the graph are shaded. We're looking for all the possible regions of the graph. Unlike and, where we're looking for the overlap that both of them meet, or is only concerned with one or the other. So it's just all the possible regions of the graph that end up as shaded. Starting with this first one here, in order to solve it, it's still 2 steps, so it shouldn't be too tricky. I would add 11 over to the other side to try to get the negative 10x alone. That would result in having negative 10x is less than negative 1 plus 11 positive 10. Now, in order to get x alone, we need to undo that multiplication of negative 10 times x. I would divide by negative 10 to make that happen. When we divide by that negative, we need to flip-flop that inequality, don't forget. So we're going to get an answer here of x is greater than negative 1. That's 10 divided by negative 10. All right, hopefully no issues on that. So values for x that would work out for this inequality could be those that are greater than negative 1, or it could be those that are this. Subtract 10 from both sides in order to solve this one. This gives us 3x is less than or equal to negative 5 minus 10, negative 15. Let's divide both sides by 3. No reason for flipping the inequality. We don't need to do that. Dividing by a positive number, so no problem here. We get that x is less than or equal to negative 15 divided by 3, negative 5. So the values for this particular inequality that would work are those that are greater than negative 1 or less than or equal to negative 5. So let's see what that would look like on a number line. Okay. Again, I don't require you to draw the inequality number lines to scale, but I certainly do ask that you keep in mind that negative 1 is greater than negative 5, so negative 5 should be below it, should be to the left of negative 1 on the number line. But anyway, graphing stuff here. So we got x is greater than negative 1. That's going to be an open circle on negative 1, and we're going to be shading to the right, like that. Or x is less than or equal to negative 5 is going to be a closed circle on negative 5, and we're going to be shading to the left. So really, any number that's in either of these two regions, either bigger than negative 1 or smaller than negative 5, would satisfy this inequality because it would make one of these two things true. These numbers in the middle, like for example, negative 3, we wouldn't be so happy with that because negative 3 is neither greater than negative 1 nor less than or equal to negative 5. Okay? Hopefully that makes sense. Let's now work on an and problem together. Hopefully you got that right too when you tried it on your own. With and problems that are written in this way, remember that these are sort of two inequalities like kind of smushed together, right? It's like an inequality sandwich that we need to deconstruct. We have this first inequality here and this second inequality here. Okay? So with this first inequality, I'm going to pull it apart over here and say that we have that negative 36 is less than 3x minus 6. And we also have with the second equality that that 3x minus 6 should be less than or equal to negative 15. I was getting ahead of myself with the negative. Okay? Now that I have those, we can just solve each of them independently, and then we want to find that overlap where they both exist at the same time, because this 3x minus 6 piece has to be greater than negative 36 and at the same time less than or equal to negative 15. So we see why it's an and problem, because it has to satisfy both conditions at once. So let's make it happen. In order to do that, we're going to solve each one independently. Like I said, we'll add 6 to both sides to get x alone. Gives us negative 30 is less than 3x. I will divide both sides by 3. No need for inequality flipping because we're dividing by a positive. We get negative 10 is less than x. Okay? If you prefer to have your inequality written with the variable on the left side, as many students do, totally fine. We can just rewrite this as saying that x is greater than negative 10. Having the inequality face the variable still, right? It's still facing the same way. I just happen to read it from left to right here. X is greater than negative 10. X is greater than negative 10. Okay? And that's only if you're comfortable doing that. Or if you're uncomfortable with this, rewrite it like this. If you feel comfortable about this, then, by all means, just leave it there and graph that. If you can graph that and say, well, all your x values for x should be bigger than negative 10, then you don't have to rewrite it. It's just an option that you have. Okay? Now we can solve the second one as well independently by adding 6 to both sides. We would get that 3x is less than or equal to negative 15 plus 6, which is negative 9. Divide both sides by 3. Again, no need for flipping. This time the x will already be on that left side, which is nice. We get that x is less than or equal to negative 9 divided by 3, negative 3. So, with this being the case with an AND problem, I need to find values for x that are both greater than negative 10 and less than or equal to negative 3. No problem. We can use a number line to figure that out. Okay. Suppose that negative 10 is right here. That means we'd have negative 9, 8, 7, 6, 5, 4, 3. Negative 3 would be here. And think about what these shadings would look like. If I have values for x that are greater than negative 10, I'd have an open circle on negative 10, and I'd be shading to the right. X is less than or equal to negative 3 means I would have a closed circle on negative 3, and I'd be shading to the left. So what region of the number line is going to get overlapped and shaded by both of these? It's going to be this middle part right here. Do you see that? Because this x is greater than negative 10 will start here and go forever this way. This x is less than or equal to negative 3 will start here, shade it in, and go this way. And so this part of the graph gets covered by both. All right? So that should be a nice little recap of how to handle some compound inequalities. Hopefully no questions. If you do, don't be afraid to reach out. All right? Anyway, now that we did that, let's go into some, it's like, bam, word problems. All right? You didn't know that was hiding there the whole time, did you? Surprise. I have full of math surprises all the time. Anyway, let's go into some word problems. These word problems you're going to notice are very, very similar to the ones we did yesterday. But this time we're going to be talking about things being between a certain amount or greater than or less than a certain value. So they're going to have that compound flavor to them, so to speak. But they're really similar. So starting with this first problem, I like this one a lot for a starter problem because it doesn't really require much math. It's really focused on deconstructing the words into an inequality. So take a look at this first problem here. It says, at the movie theater, anyone that is under the age of 6 or anyone that is 55 and older can qualify for a reduced admission price. Write an inequality that represents the situation and graph the inequality on a number line. So anyone that is under the age of 6, let's suppose a person's age is X. I don't know what their age is. So any age that's less than 6 can qualify for that reduced price, right? So if your age is X and X is less than 6, then you'd be A-OK, all right? Or, notice this is an or problem because there's kind of two things going on here. You even see that keyword or showing up in the word problem itself. Anyone that is 55 and older can also qualify for this senior discount on this end, but this reduced admission price. 55 and older, that means your age, X, could be greater than or equal to 55. And if you're either of these two cases, you have that reduced admission price. Does that make sense? So there's really not much math to do here, which is why I like it as one to get started, because it's just about deconstructing these words and turning them into an inequality. Now I can graph this on a number line. Obviously, I'm not going to draw this to scale because I'm not going to draw 55 tick marks. But we would have, suppose 6 is way down here and 55 is way up here, right? The values for x that would make this true are those that are less than 6. So we have an open circle and we're shade to the left. Or those that are greater than or equal to 55. Closed circle on 55, shade to the right, which represents those that are greater than or equal to. All right, so that's that first problem taken care of, right? Very straightforward, just literally translating our sentence here to a number line. So kind of cool how we can represent that. All right, that's something that you see pretty commonly. You either get a child discount or a senior discount. I kind of fall right in the middle right now, but I'll take advantage of this when I get here. No rush, though. No rush. All right, moving on to the next problem. The next problem says 6 more than the product of -3 and a number is between 15 and 21. So here we go with these words that we have to turn into an expression. 6 more than the product of -3 and a number. Well, let's think about that. If my unknown number is x, right, I'm doing the product of -3 and that number, and then I'm adding 6. So the product means multiply. Product of -3 and a number is going to be -3 times x. 6 more than that means we're going to take -3x and then add 6. And that number has to be between 15 and 21. Notice that that does not include 15 or 21, right? Just saying that it's between 15 and 21. So like 15.1 would be fine, but not 15 itself. So we would say that this number is between 15 and 21. Hopefully you can see how I did that. Pretty fancy stuff, right? 15 would be less than whatever this quantity happens to be, which would be less than 21. Okay? Notice it's strictly less than and not less than or equal to. If you feel uncomfortable writing it in this like hybrid inequality way, this compound inequality notation, you could certainly write them separately. And you could say, well, if this product of -3 plus 6, -3 times a number plus 6, has to be between 15 and 21, then that means that -3x plus 6 has to be greater than 15, and -3x plus 6 has to be less than 21. Okay, that's absolutely fine if you want to write them separately. You kind of end up having to do that anyway, where you need to break this hybrid apart. But this is really what it would look like, something like that. Hopefully that makes sense to everybody, right? Remember, product means multiply. Now we can go ahead and solve these independently and find out what values for x make this true. I can subtract 6 from both sides here. Should be pretty straightforward. I get -3x would be greater than 15 minus 6, which is 9. Now I am doing -3 times x, so I need to divide by -3 to undo that multiplication. Dividing both sides by -3, I will get x is less than, notice the inequality flips because we divided by a negative, -3. 9 divided by -3. So we need to make sure that our x values are less than -3. And also, we need to make sure that if I subtract 6 and subtract 6, we get -3x is less than 21 minus 6, 15. Divide both sides by -3. Inequality is going to flip again. We get that x is greater than -5. So we have to make sure that our values for x are less than -3 and at the same time greater than 5. So what will that look like? Consider our number line right here. Here's -3. Here's -5. Our values for x have to be less than -3, so open circle and shading to the left. To the left, 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 right? And greater than 5 means they have to have open circle, shading to the right, 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 to the right. So what part of the graph is both less than -3 and greater than 5? It's this middle section right here. So these numbers are all the possible numbers for x, okay? Which includes -4, because it's right sandwiched smack dab in the middle. And don't forget all those fractions and decimals in between, -3.5, -4.5, etc. Okay? Any questions about how that was done? Again, hopefully letting it sink in a little bit, making sense. All right, one more problem to do for the day. Nice big problem here. So you didn't know there was a problem on the back either. So many surprises in this video that you don't know about. Okay. This problem says that this is similar to the problem we saw yesterday with test averages, but now we're going to try to look for a range. It says Marcus had 3 tests so far in Algebra 1 CP and scored an 81, 85, and 96 respectively. Not bad. He has a 4th test coming up and wants his test average to be at least an 81 and at most an 87. I don't know why he would have a maximum test average. Wouldn't you want to get it as high as possible? But whatever. We're not going to judge. He wants to get at least an 81 and at most an 87. What is the range of possible test scores you can earn to achieve this goal? So first of all, we're talking again about the average. In particular, here we have the average of 4 test scores, 3 that we know and 1 that we don't. To find the average of these 4 test scores, we're going to take the first test score combined with the second test score, combined with the third test score, and the 4th one. And since there are 4 things, we're going to add them all up and divide by how many there are, so we would add them up and divide by 4. Right? So to find the average of these 4 things, we would add up the 4 test scores and divide by how many there are, divide by 4 in this case. If there are 5 tests, we would add them all up and divide by 5. If there were 3, add them all up, divide by 3, etc. All right, anyway, so Marcus on these tests got an 81, 85, and 96 respectively. Let's fill those in. We have an 81 for test 1, an 85 for test 2, a 96 for test 3. Now, I don't know what test 4 is. That's the whole point, is to try to figure out what are the possible scores for this 4th test that we can earn. So we're going to use an x to represent that, all divided by 4. Now we have to set up, so we have our middle part. Now we have to set up our inequality. He wants his test average to be at least an 81 and at most an 87. So if it has to be at least an 81, that means that this has to be greater than or equal to 81, right? And that would mean that this as well, 81 plus 85 plus 96 plus x over 4, has to be less than or equal to 87, right? Because if it's going to be at least 81 and at most 87, then it has to be between there, okay? You can, if you so desire, write this as sort of a compound inequality and then try to pull it apart. It would look like this. We would have our 81 plus 85 plus 96 plus x over 4 would be between 81 and 87. So 81 would be less than or equal to this, which would also be less than or equal to 87. If you're comfortable writing it this way, with sort of the lower boundary and the upper boundary here and here, or you're comfortable just doing it separately anyway and saying, well, this stuff has to be greater than or equal to 81 because it has to be at least 81, smallest, and this stuff has to be greater than or less than or equal to 87 because it has to be at most 87, right? Here's greater than or equal to 81, less than or equal to 87, whichever you're comfortable with. If you're comfortable writing it in sort of this separate way right off the bat, that's fine. If you're comfortable writing it in this hybrid way right off the bat, that's fine too. Whatever floats your boat. All right. Regardless of which way you pick, though, we now have to solve it, and we have to figure out, well, what values for x are going to make this work. Well, what I would do here is, I need my handy-dandy calculator. I would certainly try to combine all those like terms, because there's a bunch of them. In the numerator, we have 81 plus 85 plus 96. We would get 262. So let's simplify our work here. We get 262 plus x over 4 is greater than or equal to 81. I would now, in order to get at that 262 plus x, I need to get rid of that big old division by 4, and I do that by multiplying by 4 on both sides. That gives me 262 plus x is greater than or equal to, I should be able to do this in my head, I think 324. Just going to double check. Yeah, 324. Very good. Now we need to subtract both sides by 262. That's really the last step. And we get that x has to be greater than or equal to, let's see, minus 262. We get x has to be greater than or equal to 62. That's a good start. And let's figure out the other one. Here, again, we have all those same numbers being added up, so we'll just save ourselves some work. 262 plus x, all divided by 4, has to be less than or equal to 87, because that's our maximum, that's our ceiling. Again, I don't know why he wants a max test score. We're not going to judge him, right? We're gonna go about our day, right? Notice it got. Do you notice how dark it got in here? Holy cow! All of a sudden, I've been teaching math for a long time today. I think it was so bright when this video started. Now it's like dark, and you can see the reflection of my screen. Look orange. Look like I have a bad spray tan. Anyway, here we go. We get rid of this big division by 4 by multiplying by 4 on both sides. We get 262 plus x is less than or equal to 87 times 4. 87 times 4, we get 348. Like so. One more step again, we're going to subtract that 262, and we get that x is less than or equal to 86. So if x has to be greater than or equal to 62 and less than or equal to 86, then we would wrap up this problem by saying what's the range of possible test scores. So Marcus, the guy in this problem, can get any score greater than or equal to 62 and less than or equal to 86. So he's got a nice big large margin to work with, right? Anything that's less than 62 would push his average below his desired 81 minimum, and anything greater than 86 would push his average above that desired 87 maximum. Okay, so just keep that in mind. If you want to, you don't have to, but if you want to, you can graph this on a number line and show that if this is 62 here, clearly not to scale, and this is 86 here, then your values have to be in the middle from 62 to 86, because it's what would get shaded in by both of those things. All right, so hopefully that was helpful. Hopefully it was helpful to do a nice review of some compound inequalities first, right? We just saw an OR problem and an AND problem, textbook. This is exactly something you'd see on an assessment. We then saw a couple of word problems, the first of which just involved translating the words to a compound inequality. The second one involved translating the statement 3 more than the product of -3 and a number and working it out in an inequality with AND, because it has to be between these two things, so it has to do both at the same time. And lastly, we saw a word problem in which we have this test average that has to be between and including these two numbers here. And so you kind of have these two inequalities. You could write it like this if you wanted to, if you feel fancy, or you could do both separately and say, well, it has to be bigger than or equal to 81, and it has to be less than or equal to 87. Okay? Hopefully that was helpful. Tomorrow, you guys are going to get sort of a wrap-up review kind of day where we pull compound inequalities and word problems all together. I have a nice variety of problems to show you tomorrow, so look forward to that. All right. Please try the practice problems that are also uploaded on Google Classroom. Those should be very helpful for you. But other than that, I hope you have a great day. Study, prepare for your progress assessment and summative coming up soon, and I will see you guys later. Have a great day.